Our webinar on the Exigence Green ICT Digest. Let me first take you through the agenda. So we'll start off with a brief introduction into the Green ICT Digest, including a brief introduction into the project Exigence itself, which I will do for you. Then I'll give the floor to Melissa to give us a demo tour of the Green ICT Digest itself. And then we'll dive into a number of capita selecta. Just to give you a taste of Green ICT Digest, we will drill deeper into 4 of the organizations that we've been explored. Zoran will give a presentation on Etsi, Marvin on ITOT, Ariane on greening of streaming. At the end of the presentation, I will come back to you with a presentation on 3GPP. And after that, we will go for Q&A. Okay, so your speakers for today will be Zoran from Huawei, Marvin from Datacom, and Ariane and myself from TNO. Project Exigence is part of the YesNet joint undertaking. This project started beginning of this year and will run until half of 2026. We have 10 partners on board. You see them here on the slide, divided among industry and research. So about Exigence. The aim of Exigence is to reduce the energy consumption and carbon impact of ICT services, explicitly taking a holistic end-to-end approach, spreading across domains. So you see the picture at the bottom here, and each of the purple boxes is a domain, and it's controlled possibly by a separate entity. So for example, the application service provider could be an over-the-top video provider, streaming a video through one or more ISPs, fixed networks, to a mobile network, and then finally to an end-user device like a mobile phone. All 4 of these are different domains, and we're interested in getting energy consumption and energy efficiency and carbon impact information across the domains, and also to do optimization across the domains. So to do that, Exigence is addressing 3 pillars: measuring energy consumption and carbon impact end-to-end, using that information to optimize the orchestration of the system or the settings of the system to minimize energy consumption and carbon impact, and finally, to make all of that work, all the domains, all the stakeholders need to get something out of it, and therefore at times we need to create additional incentives, and also that's in scope of Exigence. In order to be able to do all that, we need to address a number of topics. We need to define metrics for energy consumption and carbon impact. We need to perform measurements to obtain the information, which subsequently we need to aggregate across all domains in the chain. We may need to attribute some of the energy consumption or carbon impact to, for example, individual users or individual user flows. And we want to use all that information to optimize the system. Well, like any self-respecting research project, the first thing Exigence started to do was a state-of-the-art analysis. So we tried to identify a number of organizations and sources of people already working on metrics, measurement, attribution, etc. And we found quite a number of SDOs like 3GPP, Etsi, ITOT, and IETF, several industry associations such as the Greening of Streaming and NGMN, and different other sources. In total, we find about 90 different documents. For instance, a single standardization document is counted as one. And for each of those, we made a summary. We briefly indicate the scope of the document and then summarize the aspects relevant to Exigence, so about metrics, measurements, attribution, aggregation, etc. And we pinpoint the relevance towards Exigence, the relevance towards the different tests of Exigence which correlate with metrics, measurements, attribution, etc. And when doing that, we realized ourselves, well, this end-to-end approach to Green ICT is an emerging field. And to our knowledge, this is the first encompassing overview addressing this field. So rather than keeping it to ourselves, we thought this may benefit a larger community. And therefore, we went public with the Green ICT Digest, which is basically part of our website, a wiki, if you like, which shows all the information that we gathered and interlinks it. So the Green ICT Digest enables you to get a quick overview of the field, You can zoom into different aspects using so-called tags, for instance, into the metrics or the measurements or all the documents that discuss aggregation. And that way you can compare approaches of different organizations, see their similarities, their difference, and where are the gaps. And that provides a starting point for innovation, but also a focal point for discussion and cooperation. And in large, it will help shape us a community around this new field. So with that, I'm finished with the introduction. I'd like to give the floor to Melissa for the demo.
Thanks, Ebert. So, once we are on the Exigence homepage, we navigate to the Green ICT Digest from the menu. One thing to note is that to simplify your search, the Green ICT Digest page offers you 3 options for finding specific standardization documents. The first option is the search bar. The second option will be by categories, and the third option will be through tags. So now let's have a closer look at those options. The first option is the search bar, where you can enter a keyword to discover relevant documents. For example, if we type in standardization, the system will retrieve all documents within the digest that correspond to that specific keyword. And each category will feature pages summarizing one or more associated standardization documents. As you can see, it's quite easy. If you are not sure now which keywords to use, no worries. You can explore the second option with the voice categories such as FreeGPP, Etsi, IETF, and more. Let's select, for instance, FreeGPP. The system again displays all the standardization documents related to that chosen category. If we go for the tags, if you're familiar with specific tags, you can select one to refine your search further. For instance, if choosing data collection will once more yield all documents pertinent to that topic within the digest itself. Now let's return to the Green ICT Digest homepage. And I'd like to go through with the category. Let's take FreeGPP and examine one of its pages. Okay, so let's take the first one. At the top of the page, you'll notice that various tags related to the particular document are displayed. To the side, there is an index box that you can make use to facilitate navigation, especially since some pages can be quite lengthy. Last but not least, throughout the pages, you'll find 2 types of links. The first will allow you to download the complete original document for offline access. The second one is a bit different. It will redirect you to the specific document referred within the Green ICT Digest itself. So overall, the Green ICT Digest offers a user-friendly experience with multiple search options, including keyword search, categorized documents, and tags, facilitating in this way the easy access to relevant standardization information.
Great, thank you, Melissa. So now for a taste of the Green ICT Digest, and I would like to give the floor to Zoran for the topic on Etsi.
Thanks a lot, but before I start, let me just ask, you hear me well? Everything is okay. Thanks. So a quick, brief intro about Etsi. One page telling in principle what is Etsi and what it does. It's, I guess all of you know, it's a European Telecommunication Standards Institute which focuses on development of and testing of globally applicable standards. As I pasted from their web page, that Etsi offers an open, inclusive, and collaborative environment to work on these standards. Etsi has developed a lot of valuable standards in the past and will present actually an important target of our project. In particular, what I found interesting and relevant to our project so far in the past standards of Etsi, that is the work of so-called Environmental Engineering Committee of Etsi, so TCEE. And that committee develops standards for reducing the eco-environmental impact of ICT equipment. And in general, focusing on the whole life cycle of that equipment, starting from production and their usage in the networks and services, etc. Well, please, next slide. Among technical specifications which we found most relevant from Etsi, I think I can mention these 3 or 4, so to say. One has 2 parts which are relevant to us. The first one is specification 203228, which is named Assessment of Mobile Network Energy Efficiency. That specification defines metrics for energy efficiency of mobile networks, as well as parameters that play a role and conditions in which concrete measurements are performed. Actually, this specification was done in collaboration with ITU and is actually the ITU specification L1331. It will be in a little bit more detail discussed by Marvin in 1 or 2 slides. And therefore, I will not go into any detail here. You will get some details in a minute. The other specification, which is of interest, is about metrics and measurement methods for energy efficiency of wireless access network equipment. So the focus is strictly on access and on how we actually measure the energy efficiency of that equipment. It comes in 2 parts. In part 1, the focus is on the static measurement methods. And in part 2, the focus goes to dynamic measurement methods. Under static measurement methods, we consider the cases. They consider the cases where the load is actually static. So there are well-defined load profiles under which the equipment is tested. And that load is actually static. So there is no mobility, there are no dynamic changes in the environment, etc. Then the part 2 of this specification focuses on dynamic measurement methods where dynamicity is present. And it actually does for all access methods except 5G. And then the specification 103786 fills in that missing part by providing the test environment or describing the test environment for the 5G case under dynamic load. These were the specifications which we actually read and to some degree well understood how they can be relevant for our project. And with that, I would stop and give the floor to the next speaker. I believe it's ITU, okay. But you about I get back to you.
Thanks, Zoran. So next speaker is Marvin on IQT. Please go ahead, Marvin.
Thank you so much, Evo, and hello everybody. In the Exigence Green ICT DIGEST, we have included the telecommunication standard of the International Telecommunication Union. And just a little background about the ITU. The ITU has been a specialized agency of the United Nations since 1947, but it was even established before the United Nations in 1865. At that time, the name and functions were related to telegraphic networks, and today the ITU develops international standards for telecommunications and ICTs, and these are known as recommendations. Regulators utilize these recommendations to set their national telecommunication ICT rules. So therefore, the adoption of these recommendations ensures interoperability and efficient global communications. We know, or the ITU is well known in relation to the spectrum that is commonly allocated for mobile networks, such as GSM, 4G, and 5G, as well as telecommunication technologies standards, including a variety of standards such as video and TV, as you can see in this box of different study groups. But the ITU also works on and develop green ICT recommendations, such as a standard that help reducing environmental impact of ICT, also develop guidelines for energy efficient ICT, and methodologies to evaluate the environmental impact of ICT technologies, including energy consumption and greenhouse gas emissions. The ITU developed the standards through study groups. You can see in this box the current study groups, and study group 5 is the one that developed methodologies to evaluate ICT effect on climate change, and also they publish eco-friendly ICT guidelines. Next slide, please. Related to Exigence, the ITU section, as was presented by Melissa, includes the most relevant recommendations that we found in relation to energy efficiency and evaluating the conversions between energy and carbon equivalent measures or metrics. Within these, we can find the standardization terms and trends in energy efficiency in recommendation L1315. Also 5G energy saving technologies, including artificial intelligence and best practices for 5G. Total network infrastructure energy efficiency metrics. We can use L1350 and 1351 for the assessment of base station energy efficiency metrics. And to compute the relation or the conversion between energy and carbon data intensity, we can use the ITU recommendations 1330. For example, in a 5G network, L1331 that was mentioned by my colleague Soran before, we can use this recommendation to, or one operator can use this recommendation to monitor the data energy efficiency as a KPI. And in this recommendation, you measure the data volume transmitted and divide that by the total mobile network energy consumption. And that KPI is given in bit per joule. That's a classical energy performance metric that you, as an engineer, commonly have found. But we can use any performance and divide that between the energy that is related to that performance to compute those KPIs. For example, another KPI is the mobile network coverage energy efficiency. When you take the coverage, the area coverage by the mobile network and divide by the energy consumption. And with that, you get the square meters per joule as a KPI as well. That is important to monitor by the operators and it's commonly used. But also in this recommendation 1331, which is related to 5G, there is another KPI which is called the energy efficiency for network slicing. And if you know, in 5G, particularly network slicing allows the creation of multiple virtual networks within a single 5G infrastructure. And in this KPI, we take the performance and divide that between the energy consumed by the network slicing part, just as it could be a separated network, but we consider only the energy associated to the slice. But with 1331, we measure energy efficiency, but and we can compute the total energy consumption. But to convert that into carbon equivalent, we can use recommendation L1333. By using this recommendation, we can convert or translate the energy consumed into carbon equivalent. This allows to measure the environmental impact, including the mix of energy sources, which is something that is not measured into the energy efficiency KPI of 1331. Finally, another important measure that one operator will do, we want to reduce the energy consumed or become more energy efficient into a network. Then we can also implement energy saving techniques. And for that, we can utilize the recommendations 1390. In this figure that you can see below, there is a true graph, one ideal that goes from 0, and on the horizontal axis we have the load, and on the vertical axis we have the power. So basically, the power consumption, even at 0 load, when you don't have traffic, is not 0. That means even if nobody is using the network for a site, the energy is consumed. And some energy saving techniques can be applied by operators when we have this low traffic on particular sites. And in L1390, the energy saving techniques are classified as, you can see in these 4 categories: time domain, spatial domains, frequency domains, and power domain. Hence, utilizing these 3 recommendations as an example, an operator should measure the KPI before and after implementing these energy saving techniques. And by that, he can monitor and report their network energy efficiency performance, which impacts directly into the saving cost. But also, they can convert that into CO2, which measure the impact in the environmental environment. You can read more about this in the IDUT Green ICT Digest. I give the floor to my colleague Ariane, that will present the next ICT Digest.
Please, the floor is yours, Ariane.
Yeah, thank you, Marvin and Ewout, and also thank you all for attending this webinar. I'm going to tell you a little bit about greening of streaming. It is a member organization, slightly less than 20 members, and working together with 8 other organizations there in the global environment. The organization it is addressing the concerns about the energy impact of video streaming. Video streaming is also one of forms several of our use cases within Exigence. So there is some relevance there. You know that well, 80% of the internet traffic is related to video. So if you can find energy savings in that arena, it can contribute quite a lot there. The organization is not really a writings organization. I show you 2 papers that have been addressed there, and it's more in the domain of doing real measurements in networks that are out in the field. So it's not working so much with lab environments. One of the things that they are doing is doing measurements on end user devices, and basically they're using these kind of plugs for it. I hope you can see it. It's an commercially off-the-shelf component you can buy. It does energy metering for you, and well, it works next to very much of those kind of devices with apps on your mobile phone. But the nice thing about this TP-Link device is that you can also link it up to an overarching account, and by that way the organization is doing measurements on many devices, collecting from different people in their homes. I think we can go to the next slide there. So one of the things that make this organization relevant is in the definition of some lexicon, the power of and sleep and standby terms that we all use and sometimes quite randomly are defined in this organization. So that helps clearing out that term. Also, the term watts is of relevance there. The energy consumption method that they are using is mentioned there and recently, but that is not yet in our digest. They had a good and also enlightening discussion about attributional and consequential energy consumption usage. I think that folded directly back into the organization, because it's also one of the things that we have been discussing. So I think that will be included in the digest real soon. That concludes my presentation. Go to Ewout now.
Great, thank you, Arjan. So now for the last part of the presentation of 3GPP. 3GPP, the third generation partnership project, is a worldwide standards body, the worldwide standards body for mobile networks, and it has been so since 3G, since the third generation. And basically, there is a new generation of mobile networks about once every decade. We've seen 3G, 4G, 5G. 5G is nearing its completion in terms of standardization. We are now at 5G advanced, final stages of 5G. And first discussions on 6G use cases actually starting right now. At the final level of granularity, 3GPP generates a new release of standards about every 1.5 or 5 years. So for every generation, you will see multiple releases. You will see it improve step by step. Currently, 3GPP is working on releases 19 and 20. And why 2 releases at the same time? That's because they follow a staged approach. So while in stage 20, they are defining the use cases and requirements overarching for the new generation, in release 19, they are really working on solutions, so architecture and actually writing technical specifications. Well, up to release 18, which was finalized earlier this year, 3GPP was what I would like to call internally focused with regards to energy efficiency. So the drive was to make the mobile network as an entity as energy efficient as possible. And we obviously take that as an input in Exigence. So this is represented in one of the 2 pages on 3GPP up to release 18 is really input to Exigence. From release 19 onwards, specifically release 19 and 20, there's an ongoing study called Energy Efficiency as Service Criteria. And this is really about opening up the mobile network in terms of energy efficiency and enabling end users and verticals to include energy efficiency as a criterion for consumer services. So you can not only ask for a certain bandwidth, a number of bits per second or a certain latency, but you can also ask for optimization of a certain level of energy efficiency or asking how much energy is being consumed. In technical terms, that means that energy efficiency information is exposed to third-party application functions. And that way, by opening up, the mobile network ecosystem may play a role in end-to-end energy efficiency optimization scenarios as targeted by Exigence. And since this is ongoing work, it's not just input for Exigence, it's also very much output for Exigence. Exigence wants to contribute to this standardization and is doing so to help move 3GPP in the right direction to make our vision of an end-to-end energy system a reality. So let me dive into first the part up to release 18, the finalized specifications on energy efficiency. There are 5, you'll find 5 on the page in the digest. I've only mentioned the 3 most important ones. Technical specification 28.310 discusses use cases, requirements, and solutions for energy efficiency within the 3GPP network, because, as said, up to release 18, it's really constrained to the network itself. So switch of a base station, if you have little users, then extend the reach of others is an example. Technical specification 28552 has a large number of performance measurements, both for the radio access network and the 5G core. And there are also a few of those relate to energy. And those, by the way, only for the radio access network. Interesting to note is that this specification makes a reference to the Etsi 202.336-12, which is also summarized in the digest as the way to obtain the energy measurements, and also as specifies how high the resolution and accuracy should be. Finally, technical specification 28554 is, by my understanding, the most interesting for our purpose. It defines metrics, a lot of metrics, including some energy-related metrics. Specifically, it defines metrics for energy efficiency and metrics for energy consumption, where energy efficiency is defined as the energy consumption divided by the useful work. Most interesting is the discussion on slices, which Marvin also touched upon. There are different types of slices in 5G networks. Enhanced mobile broadband slices are about transporting a lot of data. So there the useful work is the data volume. So you can talk about microjoules per bit or whatever measure. Whereas for ultra-reliable low latency communication, you need fast response time, low latency. So 1 over the latency and 1 over milliseconds is a figure of merit, and that's useful work that you divide by. Whereas for massive IoT applications, the number of simultaneous subscribers on the network or on the cell is the figure of merit. So you talk about energy consumption per connected consumer, or per connected subscriber. Okay, that concludes release 18. Now let's go to the future, release 19 and release 20. And first I need to explain about SA1 and SA2. SA1 means System Architecture 1, and SA2 means System Architecture 2, and they are both working groups of 3GPP. And SA1 is looking at use cases and requirements for the next generation. And once they are done, SA2 will pick up and identify the key issues to realize those requirements and subsequently come up with technical solution and put them in specifications. Well, as said, there's a staged approach. So at the top of the screen, the top bar of the picture, you see the work on release 19. They had a technical report 22882, which describes the use case requirements for release 19. Then all those requirements from the different use cases were consolidated and put into one big document, the specification 22261. Specifically in section 6.15a, you will find the requirements with regards to energy efficiency as service criteria. Then the work was handed over to this group SA2. And they've recently concluded this technical report 23700-66, which identifies key issues and solutions. And currently they're continuing their work with so-called normative work. So they're writing this into technical specifications. At this moment, release 19 only considers best effort service. More demanding services like real-time service are left for release 20. And you will find they defined a new network function, the energy efficiency control function, known as EECF, and additional procedures to actually have solutions for the requirements for release 19. Release 20 is only in SA1, it's just starting. Early this year, a study item was proposed by China Mobile to continue the study on energy efficiency as service criteria. Different Exigence partners who are represented in 3GPP supported that study item proposal and also managed to make the scope a little bit wider to serve the purposes of Exigence, to get our use cases in there. Subsequently, work started on the study, and currently there's a draft document, Technical Report 22883. And in there you will find 8 new use cases. 3 of those have been submitted on behalf of Exigence. Those are the sections 5355 and 58. Also interesting to note is Annex A. It's a one-page summary of this very Green ICT Digest, which I wrote to basically highlight that there are other standardization organizations next to 3GPP that are also targeting this. So as a motivation for 3GPP, we should work on this end-to-end vision. And that concludes my presentation on 3GPP. So I'd like to hand over to Melissa for the Q&A.
So now we are within the Q&A session. You can ask your question. Please use the React button and raise your hand, and we can go through one question by one question. So I'll have a question for you, Marvin. You mentioned that energy consumption and carbon intensity can be used to compute the CO2 emission at network level. How will Exigence apply this at the user level?
That's a good question, Melissa. Maybe if you go to the slides from my IETF to better explain.
Sure. Let me just scroll back.
I think it's slides 19.
This one or the next one?
The next one, right. So there are several standard terms. Standard terms and trends in energy efficiency, for instance, provide us definitions that can be used at different levels. But you are right. Exigence is looking beyond a single network and is a cross-domain network as well. So that is new and has to be introduced. But these terms and trends and energy efficiency definitions can be reused in our metrics. Also, the applications over different domains at the network level are important to be reported as a green environmental impact in general. But Exigence can utilize these definitions at a lower granularity. That means it will go below the network level to the user level. So, for instance, in recommendations 1331, we can reuse this data volume definition, but instead of dividing the volume or computing the volume for the whole network, we can compute the volume that is transmitted by the user in the period for instance, for a real-time video, and divide that by the energy consumed over the time for transmitting that to the user. And by that, we can measure and apply the same metrics, but with a lower granularity at the user level. And measuring the energy as is done for the network level, we can convert also using similar to carbon data intensity described in 1333. We can use the emission factor to convert the energy consumed for the service into carbon impact and report that to the user. So we still can utilize this, but the granularity and the sampling and period of measurements has to be improved very much compared to the ones that we use in this recommendation at IETF, which are more at the network level. I don't know if that's...
Ewout, I see a message in the chat for 3GPP. So maybe you could...
Sure. So the question is simple feedback on 3GPP. A priori, it seems to me that we are only looking at the aspect of more efficient use of energy consumption. Very well, but this is a reduced aspect of what you really need to do and look at ICT sustainability. Otherwise, it can be counterproductive or more polluting. So we need to consider the entire life cycle. Also considering rebound effects and induced effects, if I rephrase it correctly. First of all, we are not only looking at energy consumption, we are also looking at carbon impact. And we want to do that in real time, in the sense that at the moment the energy is consumed, we want to know the energy mix. And that's also what Exigence is gearing up to make the architecture suitable for, to basically really reduce carbon impact and not just buy and sell carbon certificates, which at least some consider to be more like greenwashing. But you also raise an important point about, should we just look at energy consumption and carbon impact of the use phase, or should we take a cradle-to-cradle approach where we look at the entire life cycle, which includes the energy needed to produce the equipment, the energy consumed by the people programming the equipment, transporting the equipment, installing the equipment, etc. Well, in Exigence, we've chosen not to go that far. So our focus is purely the operational phase, taking the end-to-end carbon considerations, and so the decision whether to replace equipment by newer equipment, which is more energy efficient, but which obviously also takes energy to produce. So throwing away old equipment, that in this case will be left to the operators or the owners of the equipment to make that computation. That's not in scope of Exigence, also because it would make the computations very complex, and with that also a lot more fuzzy, because it's very hard to get accurate estimates. And we are also driving in Exigence to really be accurate, to really measure how much energy is there, which users are using it, how to attribute it fairly. I hope that answers this question a bit.
May I also add one sentence to that?
Sure, sure.
This is actually an excellent question. When I read it, I kind of made sure that we should answer this one. Basically, in a couple of recent talks I had on the topic and on the project and so on, I said something like, in principle, I see three ways that we can reduce the energy consumption. One is that we make more efficient equipment, so better base stations, better routers, better whatever, compute nodes, etc., which do more work per used energy. Something like that. That's one way. A problem with that is, as soon as you do that, you will have more consumption and will have more usage of that equipment. So the energy will go up, probably. The energy consumption will go up. So you will have what you say, probably rebound effect. The other one, the second one is that we do some optimization. So we place distribute loads such that we reduce the total energy consumed, etc. But again, we will end up with a rebound effect and probably more usage, more consumed energy. And the third method is that we try to remove all the externalities which are bound to the energy consumption, so that we make the user aware of what is going on, because the energy is actually ultimately spent, consumed in the network because of the user, not for the sake of the operator. And this is why this is the focus of the project, that among other things, that we inform the user and that we provide incentives to the users such that they know what is going on, they are aware, and they are probably rewarded for making actions which are energy aware. I hope that I also contribute a little bit with this reply to that question of rebound effect fighting. Thanks.
We have another comment. If metrics are agreed upon from perspective to ICT customer, it would be nice to be charged per energy consumption or CO2 production.
That is actually true. I take the freedom to answer, to continue. About, would you like to comment, or I can?
You can keep on, Zoran.
Yes, that's the point. That's a good point. Essentially, what we proposed in 3GPP in the previous round of use cases with exactly that idea. We have a use case which was accepted, and Wout and colleagues may give more information on that. We have a use case which actually tells that energy-based charging will be possible, that we are going towards that requirement in the future network. So essentially, we say that the future 6G network must provide infrastructure for that sake, for that purpose. That's exactly going towards that direction. That is the direct contribution of the project so far. Get back to you about if you want to comment more on that.
Indeed. So section 5.3 of this technical report 22883 describes a use case and a single requirement, which is about charging of both energy consumption and or carbon usage for a single subscriber or a single user session. So, and this was accepted by 3GPP, so we will see this happen.
So, if I may add to the previous reply by Zoran, Melissa, can I? Yes, thank you. So, for the issue about the charging on the basis of energy and given the definition of KPIs, I think the definition of KPIs is also important for the metrics is also important for providing positive incentives, which I guess can be the first step. So instead of, let's say, charging in case of high usage with the same mechanisms and the same metrics and measurements, we can reward the user for less energy usage. And this actually will be important for the start, so that the users become more environmentally conscious and careful about their, let's say, rational usage of energy consuming devices, applications, etc. Thank you.
Anyone has a question? If not, I'd like to ask the last question for Arjan. You mentioned greening of streaming is performing energy consumption measurements. How is this relevant to Exigence?
Okay, yeah. How is this relevant? We as a project in Exigence, we are also making these kind of measurements. And greening of streaming is focusing on, well, what it says, video streaming over the internet, which is, well, one of our relevant use cases within the project. We typically talk about the cat movie viewing, while an end user is also seeing that the energy consumption is moving up, and potentially also the CO2 emissions are moving up. So these two activities, they are very much alike. So that's why I think greening of streaming is of relevance for us.
Thank you, Ora. So I think we went through all the questions. I'd like to go through the next slide. Yes. Thank you all for joining us today. And we hope you enjoyed the workshop. And it would be great if you can take a little time for a survey to just let us know your experience.